Local Foods College. This is our 6th year doing this program. It comes to you from University of Minnesota Extension. Linda Kingery is in the Northwest Regional Sustainable Development Partnership, is kind of our lead organizer, but it is a team event in organizing. We have Anna in Crookston, Karen Lanthier in St. Paul, Marie Kirsch in Brainerd, Molly Zins in Brainerd, Wayne Martin in St. Paul, Ben Anderson in Moorhead, Deb Zach in Crookston, and then myself in Winona. Kind of all have different roles in Extension, but all part of University of Minnesota Extension. It's an 8-week program. You can, of course, watch this live at home, or there are a number of sites around the state where you can gather with others and watch the program. Again, the recording is also an option as well. Our goal is to support farmers, our local food systems, also those who are avid gardeners or looking to get into these different areas and produce food, whether it's for your own consumption or for sale or a little bit of both. The online format is convenient for us. It helps us reach a wider geography than we would otherwise be able to reach just doing a ground game. So that's just a little bit about the program. Again, we're doing high tunnel diseases tonight. We've got a program on harvesting and techniques for vegetable producers. We're talking sheep, we're talking soils, we're talking the cottage food law. We'll get an update on that here in Minnesota for those people who are making food for sale at home. We'll have a poultry program, a seed saving program, and then also a little bit more geared towards those commercial producers or those who are thinking about commercially producing, some tips on how to access capital when working with the bank. In terms of the plan tonight, as you may have noticed, you're all muted because who likes that webinar where you can hear the barking dog in the background? That's not fun for anybody, and we have definitely been on those, of course. But you can ask questions in the chat. I will be monitoring that once I pass things on to Michelle. We'll stop a few times during her presentation and just check in and ask those questions of her. Again, these are recorded. They'll be posted to the Local Foods College website. Please be patient with us. So far, things are going well, but every once in a while you have an issue with this kind of setup, and you just have to work through it, and we all kind of do a face palm and just get things done. We will email you a link to evaluate each session. We really encourage you to do that. It helps us understand how well we're doing, and also helps us plan future programs as well. We're going to try and get this done around 7 p.m. tonight. So each one of these is an hour-long session. Every once in a while we run a little bit over, but we're going to try and keep all these to an hour. All right, so another feature, we have some polls that we do. And so the poll should be on the right-hand side of your screen, and you can answer this. Which best describes you? Are you an established farmer or beginner, haven't started but thinking about it? Maybe you just grow for your own, or you're interested in starting growing for your own, or something else. So you guys are a whiz with all of this. I really appreciate you jumping in and participating in the annotation stuff in the polls. All right. I know Michelle has a number of these polls as well, so you'll be seeing these through the program. Just a few more seconds there, give their chance to answer. All right, close that. Got about 20 seconds to go. So you should be able to see the results of those polls. All right. So tonight we have Michelle Grabowski. She is an extension educator with University of Minnesota. She focuses her work on horticultural crops and works with gardeners and commercial producers alike. So I am going to pass you the ball, Michelle, and you should have control.
Okay. Yep, I see my polls, which means I get to be the one in control of the mouse here. Well, thank you everyone for joining us this evening for the start of the program. I do want to talk about managing crop diseases in high tunnels tonight. So I saw we have a range of experiences. Whether you're starting a high tunnel, you're thinking about getting a high tunnel, you've already been growing in one for a number of years. Hopefully everything that we talk about tonight will be some good, solid information to help you prevent some disease problems from happening in the first place and then dealing with them when they do show up. So we talk about plant diseases. We're actually not talking about insect pests at all. Diseases are problems, plant problems that are caused by a group of different microorganisms. So our most common plant pathogen are fungi. You can see in the upper left-hand corner here, this is leaf mold on tomato, a very common problem in high tunnel tomatoes. Loves the high humidity. We see lots of fungal diseases on our crops. We also see a fair number of bacterial diseases in the bottom right corner here. That's a bacterial spot on pepper. And we also see a number of viral diseases. So our zucchini with the lovely yellow spots on it, it has a viral infection. In Minnesota, those are our three most common groups of pathogens that we see. The other two you may be less familiar with. Phytoplasma is actually a very small bacteria. So picture how small a bacteria is and try to imagine it's smaller. That actually lives inside the phloem or the vascular system of the plant. And the one that we worry about with vegetable production or cut flower production is aster yellows. So that's a term you might be more familiar with. But you can see this carrot here is doing pretty poorly and has this kind of unusual growth in the center of its bunch there. And that's because it's infected with a phytoplasma called aster yellows. Nematodes are small roundworms. They often live in the soil, but they can move up on plant material. And they infect the roots and can chew on them and cause lesions, or in this case, this is root knot nematode on a tomato root system here. In Minnesota, our cold, hard winters often knock back our nematode populations, not entirely, but enough that they are not as big of a problem as they are in some more southern, warmer areas. So depending on where you're from, I saw that a good many of us are from the upper Midwest. Nematodes may be more or less of a problem. They do show up from time to time here in Minnesota, but they're much more significantly problematic pathogen in more southern regions. Okay, so whenever you have a disease problem in a high tunnel, the first thing that you need to do is identify which organism is causing the problem. And you see my little guy down in the corner here, that's Napoleon saying, know your enemy. So once we know who the plant pathogen is, we can learn a lot about its biology that helps us choose management strategies. So what we want to figure out is, where's our pathogen coming from? How is it surviving from one season to the next? How is it spreading from plant to plant? Which plants is it going to infect? Is it only going to go to your tomato crop, or is it also going to be able to move to your pepper crop? So once you start knowing a little bit about the biology of the pathogen, you can really start to make some management decisions as far as, well, this pathogen survives in crop debris from one season to the next, so cleaning up at the end of the year is going to be really important, and probably adding in some crop rotation too. In order to get a good diagnosis, there's a lot of different resources out there. There are decent plant disease reference books for vegetable pests and pathogens. Many of them are rather expensive, and there's a lot of good online material. So at the University of Minnesota, we created an online diagnostic tool called What's Wrong with My Plant? And I created that with my colleague Jeff Hahn in entomology. So it does include insect disease and non-living problems like nutrient deficiencies and things like that. And you basically search by the symptom you're seeing, yellowing leaves, spots on leaves, and it'll give you pictures and a description of different problems that could potentially be causing that symptom. Sometimes we have enough distinct symptoms on our plants that we can get a diagnosis through a tool like that, but in many cases, you know, we find out that we can say, well, it's a leaf spot disease, but it's hard to distinguish which of these three diseases it is, in which case we recommend you send a sample to the diagnostic clinic. So this is a laboratory at the University of Minnesota, and you can submit live plant material to them, and they will look at it using microscopy, plating it out, doing a number of different techniques to identify the pathogen that's causing the problem. And then you'll get a report describing the pathogen that's causing the disease, and also often information about further management options. There is a fee to submit a sample, but in order to make a management decision, you really need to know what you're fighting. And so we really do recommend that you go ahead and send a sample when you need to. I should mention too that I'm putting up some links and a couple of different pieces of information. There is a handout on the local foods website that you can download that includes all of these links, so don't feel like you have to copy them all down right now. During the growing season, make sure that you're keeping an eye on your crop and scouting the plants regularly. So every 1 to 2 weeks, you want to go through and randomly select about 5 to 10 plants, depending on the size of the house. The larger the house, the more plants you should examine. But you want to check at kind of every corner and every situation, picking random plants, and then looking at 3 to 4 leaves. If it's a smaller plant, you can just inspect one set of leaves. If it's a plant like a really tall tomato, you might want to choose a group of leaves in the top of the plant, the middle of the plant, and the bottom of the plant. And it's important to know that many of our leaf spot fungi and bacteria will often start infecting on the lower inner leaves where the humidity is high. So that's a good place to check. And you want to look at both the upper and lower surface of the leaf, look at the fruit, look at the stems, and of course, as you're walking through the tunnel, if you see individual plants standing out like this, they're going to be ones you're going to want to stop and look at closer as well. But most of the time, we're looking at healthy-looking plants so that we can catch symptoms when they're just getting started. When we find a disease, this is actually leaf mold on tomato in the top corner here. When we get it early, then we have time to actually make some management decisions within that growing season. We may not be able to stop it entirely, but we can definitely take steps to slow it down and reduce the damage it can cause that year. Oftentimes what happens is I get calls from growers after their crop is already largely infected, and there's not a lot that we can do beyond good sanitation and planning for a better time next year. So do your scouting so you catch the disease problems early on. Okay. The next steps I'm going to go through is just different things that you can do to prevent pathogens and manage diseases when they do show up. So in plant pathology, whenever we're talking about a disease problem, we use this model called the disease triangle. And what it says is that in order for a disease problem to happen, these three things have to come together in the same place and the same time. So we have to have the pathogen, a susceptible crop, and the environment. So the environmental conditions have to be right for those, both the crop and the pathogen, for all of this to work out. Now, what we can do with this model is we can look at this and say, if I can come in and change any one of these three factors, I'll be able to reduce disease problems in my high tunnel. And so what I want to do is walk you guys through looking at the different options available for you to affect the pathogen, the susceptible crop, or the environment in your high tunnel. And we're going to start out taking a look at the pathogen. Okay, so we need to start out asking ourselves, where do these pathogens come from? You know, we start out with a high tunnel, we've prepared the ground really carefully. So how are these pathogens coming in and causing a problem? So some pathogens can come in on seed. This is something many bacteria are able to do. They can actually infect often not only the seed coat, but the embryo itself inside the seed coat. And several fungi can also infect seed. The fungi tend to be more stuck on the outside of the seed coat, whereas the bacteria are the ones that are able to move inside the seed. Pathogens can come in on infected plant material if you're purchasing transplants or fleshy seeds like potato or garlic. They can come in on contaminated compost or potting soil. They can come in on tools, equipment, or shoes. So thinking about where those have been used before they've brought into the high tunnel. If they've been in a field that had a disease problem, the pathogen could be carried in with that equipment. And insects sometimes move plant pathogens into our high tunnel, particularly viruses and phytoplasmas like the aster yellows are transmitted by insects, often with piercing, sucking mouth parts that feed on infected plants and then move into the tunnel and feed on your crop and transmit the pathogen. We also see some windborne pathogens. Some fungi are able to have airborne spores that can get blown in, and weeds can serve as a reservoir host that allow the pathogen to survive from one season to the next. So in our high tunnel, we've set this up as our ideal growing situation here, and it's to some extent precious ground. It's a lot harder to move our high tunnel if this area becomes contaminated. So what we want to do is keep this area as clean as possible. And the way that we're going to do that, oops, I guess I have my own poll that I forgot about. So I want to start out asking you a question. Do you save your own seed or trade seed with other growers? And I'm going to go ahead and add this poll. So hopefully you will see this on your screen now. Good, I see you're all starting to respond here. Okay. Just another couple seconds here, I think. Oh, it looks like everyone's gone. So we'll go ahead and close this poll and take a look at our answers here.
Yeah, I just realized that when you say close poll, it means close poll in 20 seconds, right, Michelle?
Right, yeah, you close the poll and then it keeps on going. So I'm going to share the poll results with you. And you should be able to see we've got some people say occasionally, a few people that definitely say yes, and we've got a mix of no too. So saving seed can actually be a great practice if you have, for example, an heirloom variety or a specific variety that you really like but you have a hard time finding commercially anymore. It can be a really interesting way to preserve. I know people have seed that's been passed down from family, and it's a good way to swap with other growers as well. What's important to realize, though, is that when you're trading seed and saving seed, you do have this potential that a pathogen could be coming along with the seed. So there's a couple of different things to do. Number one, if you're purchasing seed and you are concerned about the seed-borne pathogen, you can in some cases find certified disease-free seed where the seeds have been tested. And to test seed for pathogens, it is destructive. So what they do is they take a sample out of a large batch of seed and they test that sample. And if that sample is clean of the pathogen, then they can say the rest of the lot is clean. It's never 100% guarantee, but at least it's a good test. A reputable seed company will typically take a number of different steps to make sure that their seed is disease-free, simply because they want your business, again, another year. If you're saving seed yourself, the number one thing you want to do is avoid saving seed from plants that have a disease. So the way that the seed becomes infected is that the mother plant is infected, and the pathogen is able to move from the mother plant into the seed. So what you want to do is pick your healthiest plant and pick the healthiest fruit off of the healthiest plant, and those are the ones you collect seed from. Those are going to be the least likely to be carrying a plant pathogen. If you ever have any concerns about the seed, whether it's from a seed swap or maybe you just weren't sure how healthy your plants really were, there's a couple different treatments that can be done to clean seed. Both of these, there's a procedure that's well written out and described in a handout, and the handout I provided for you on the webpage links directly to this publication about the hot water seed treatment. And basically what you do is you take the seed and you heat it to a very specific temperature in water for a very specific time length. And you can see I left ranges here, and that's because every plant has their own temperature and time range that's very specific. And in the fact sheet I referenced, there's a nice table. It's pretty easy to follow. And so it's a straightforward, simple procedure to do, but you do need to be watching the temperature carefully, and you do need to be watching the clock carefully, because if it gets too hot or you heat it for too long, you run the risk of damaging the seed and potentially killing the seed itself. So you want to hit those exact temperature and time limits so you kill the pathogen, but not the seed. If this is not an option for you because of the equipment, there's some seeds we can't do this to. For example, the cucurbits just don't tolerate hot water seed treatment. We can sterilize them with bleach. So this is just 1 part bleach, 4 parts water, and you basically soak the seed for 1 minute and then rinse it in clear water for 5 minutes. What this treatment will do is it'll sterilize the seed surface. So the hot water seed treatment will kill any pathogens on the surface of the seed as well as inside the seed, so it's good for bacterial plant pathogens. The bleach treatment only cleans the surface, so it's better than nothing, but it's not going to get into the embryo of the seed and kill some of those bacterial pathogens that are capable of getting deep into the seed. Okay, we also want to start out with clean transplants that we're bringing into our high tunnels. So if you're purchasing transplants, think about purchasing them from a reputable local grower. So local, because we don't want to be bringing in plant pathogens from other places, particularly up here in Minnesota. When we're ready for our tomatoes to come in, it's still very cold outdoors, and so many of our plant pathogens are not active, whereas in more southerly regions, it's already warmed up, and some of those plant pathogens are already active and causing plant diseases. So buying locally, and then that also allows you to build up a relationship with that grower, and you can ask them about their practices they use to keep their transplants healthy. If you grow your own transplants, just make sure you start with clean pots so you can reuse your pots, but wash them with either a commercial sanitizer or a 10% bleach solution. Use new potting mix, so sterile potting media, and of course clean seed like we just talked about. Once they're going in the transplant house, you want to scout them regularly for disease. So once a week, look in for plants that might be symptomatic. And if you see things that look like a problem, take the whole tray out of this mix, simply because when the plants are so close together, it's very easy for us to be moving the pathogen around with our hands. So if we see something problematic, take it, move it to a side bench that you know is away from all these other transplants, and then pull out 5 to 10 plants and really closely examine them, looking for signs and symptoms on the leaves, the shoots, and the roots. And if you can't make a diagnosis, submit those plant samples to the clinic and keep that tray in isolation until you know what's causing the problem. If the plants don't look like they're going to make it, make sure you remove that tray and destroy it. And with a diagnosis, we'll know if there's a treatment we can do for the neighboring plants as well. Clean equipment and amendments. So we want to make sure that the equipment we're using is also clean. And there's a couple of different ways that we can accomplish this. So if you've got equipment that's going back and forth between the field and your high tunnel, just make sure that it's cleaned in between the two. So again, it's the high tunnel setup, and once we bring a pathogen into that soil, it's going to be really difficult to get rid of it. And so if it's just a tiller or a handheld shovel or something along those lines, a 10% bleach or a commercial sanitizer, making sure you're not bringing in any clods of dirt, things like that along with it, and definitely no plant material. The alternative, too, is to just keep tools that are specific for the high tunnel, especially small handheld tools. You can have one set for the field and one set for the high tunnel to make sure that you're not moving pathogens back and forth from one location to the other. Soil amendments that we bring into the high tunnel. It's great to add organic material to the high tunnel. It helps in a lot of different ways. But if you're bringing in compost, manure, straw, it's important to know where that comes from and to understand that it could potentially contain plant pathogens, weed seeds, or herbicide residue. So plant pathogens will break down in compost if it gets hot for a certain period of time, and the plant material is all broken down, so it looks like a humus material, not necessarily, so an organic soil-like material as opposed to visible plant material like stems and leaves. Herbicide residue, there are some herbicides that are used particularly on pasture grasses that are very detrimental to broadleaf crops like tomatoes, peppers, peas can be very sensitive. And we've had several cases where animals have been fed pasture grasses that were treated with this herbicide, and it actually passes right through the animal and ends up in the manure. And even if that manure is composted, the residue can be at a high enough concentration that it can injure the crop. So if you are purchasing compost that's not being created on your farm, or manure that's not being created on your farm, ask questions about the type of herbicides that are used on that farm and the type of products that are being put into the compost. And if you're not sure and you can't get that information, in the handout there's another link to a fact sheet. It's called it's about hay, and it talks particularly about this issue, and it lists 2 different laboratories that you can actually submit a sample to, and they'll be able to test for herbicide residue before you put it into that soil. It can persist for a while once it is introduced. So I have another question for you. Let's get this poll open. Hopefully you can see that now. So how hot does compost need to get to kill the majority of plant pathogens? Okay, I'm going to close this so we get our little 20-second window here. So now's the time. If you have an answer, go ahead and answer right now.
And just a reminder, we'll have a question break up ahead. If you have any questions, you can put those in the chat, and we'll address those as we move along.
Okay. All right, so I don't know if you guys can see, there should be a check mark showing the correct answer. It's 148 degrees Fahrenheit. Higher than that is not necessarily bad, although there is a certain temperature that's too hot for a compost pile. But at least 148 degrees for 21 days, so about 3 weeks. So in a well-run compost that's balanced with nutrients, you will get heat building up, and it'll help to break that down. It'll also kill the majority of plant pathogens. There's always 1 or 2 that are able to withstand this. There's always a few exceptions, but the majority of the common plant pathogens we see, 148 degrees for about 3 weeks is what we need to really see that breakdown. Okay. Oh, and there we go. There's my answer. Okay. Also think about your workers. As they are moving in and out of the high tunnels, they have potential to carry plant pathogens with them. One of our problematic viruses, which happens to be one that can survive the composting process, is tobacco mosaic virus. And it can survive composting. It can also survive the tobacco curing process. And so if you or your workers are using tobacco products, it can be transferred from the tobacco products to your hands to the crop. So it's important not to allow the use of tobacco products in the high tunnels. And if workers are using tobacco products on their breaks, It should be outside, away from the crop, and then just simply washing hands with soap and water before they return to work is important to make sure that they're not carrying the pathogen with them. So not a difficult thing. It can be pretty nasty when it is introduced, and so just making sure some of those basic rules are in place about washing your hands before returning to work is a good preventative practice. It's important not to be moving back and forth between field and high tunnel, particularly if disease occurs in one environment. Because we have the rain and less control of the environment in the field, oftentimes we'll see things start there. But particularly once we see disease, whether it's disease in one tunnel and another tunnel is clean, you always start your work in the clean area that seems to be healthy and productive, and then end your day working in the area that has a disease problem. You don't want to do it vice versa, because we know a lot of plant pathogens can be carried on our hands and tools. Okay. Weeds can also be an important thing to manage. So weeds crowd the crop. They block the ventilation, as you can see in the upper picture here. But they also can harbor plant pathogens. So many of our diseases that go to things like cabbage and broccoli and cauliflower will also go to mustard weed and shepherd's purse and any of those weeds that are in the same family, the Brassicaceae. The same thing is true with eastern black nightshade down here. It's in the same family as tomato, so many of our leaf spot diseases that go to tomato will be able to survive on eastern black nightshade. So it's important to pull those weeds both within the tunnel and outside of the tunnel to make sure that that's not a place that the pathogens are starting and moving in or surviving between crops. If you're scouting and you do find disease in your tunnel, that's when we move to the step from preventing disease to dealing with it, managing it. And one of the first steps is going to be sanitation. So you can see in this case, I put my three kind of extreme cases where I have one plant that's really been hit hard. And if you look at my wilted plant in the upper left-hand corner, this is not a plant that's going to recover and ever produce a crop for you. And so all it's doing is sitting there and providing a place for that pathogen to persist in your high tunnel and potentially spread to other crops in it. So if you see things like this, you want to bring a bag with you and a shovel, dig out root system, bag the plant, get it out of the high tunnel, and then take it back and either diagnose it with your resources or submit it as a sample to find out what's going on with that plant so you can prevent it from spreading to the rest of the crop. This would be true with viruses in particular. This is a stunted little tomato plant in the center on the right-hand side, and then the stem rot down here is white mold. And so if it looks like the plant is not going to be productive, take the whole plant out, get a diagnosis, and make your next move from there. In some cases, it's not that severe, however. We do see leaf spots, we see fruit rot, minor stem infections, and so often we'll be going through and harvesting, and you'll see things like this where the culls are left behind on the plastic. So you definitely do not want to harvest the culls and the good fruit into the same container because it will spread in storage. But at the end of the day, after you've harvested all your good fruit, send one person to go put the fruit in the cold room, but then come back and have a rot bucket. And so the last thing at the end of the day, you go through and you clean up all of these tomatoes, rotten fruit stems, things like that. Because when they're left in the tunnel, what happens is then the pathogen is able to reproduce. And if you were to look at these closely, you see these white fungal growth just covered with spores, and they're right next to the next set of fruit, which you want to be a nice marketable crop. So we want to reduce the transfer of the pathogen from these cull fruit to our next crop. And so you just get a rot bucket, pull those out, get them into the compost pile, turn it over so those spores aren't blowing around. The same can be done. This is gray mold. So this is a fungal pathogen, and you can see it's on the end of a limb. It could be very easily pruned off, and so you would want to cut it off and put it either into like a bucket or a bag, and then bring it out to the compost site. And so again, a good kind of end of the day, I'm done touching clean, healthy plants, and the last thing I'm going to do is go do a walkthrough, clean up some of these small things so that they don't spread deeper into this plant and into other plants. On the other hand, we end up with leaf spot diseases that just get out of control and progress to the point where it's really not practical to come and pull off all these infected leaves. And so at this point, what we do is we just let the crop go ahead and harvest whatever we can, and then at the end of the season, when we're done with our harvest, then we can either completely remove these plants from the high tunnel. Many of our pathogens do overwinter in this infected plant residue, so if we can get it out and put it into a compost pile that's going to heat up, that's great. If it's too much plant material to get out of the high tunnel, then as soon as you are done with your harvest, you're going to want to till it into the soil, because that's where our composting microorganisms naturally live, and so we want them to start breaking down that plant material as soon as possible. If it does go into the soil again in the high tunnel, then that's where you start looking at crop rotation so that the tomatoes are not growing in infected crop residue the very next year. Okay, we're going to another question here. Let me open this one up for you guys. So are pesticides used in your high tunnels? And I know some of you may not have a high tunnel yet. Go ahead and just answer what you would plan on. So if you think you would use pesticides in a tunnel, then go ahead and answer what you think, frequently or occasionally, rarely. Oops. I guess I didn't give you guys a never answer, so you can just do rarely. Okay, and we'll give you guys the last 20 seconds here to wrap this up.
There was one question from somebody that's on a mobile device. They said that the polls aren't working, and I don't think that the polls are going to work on mobile devices. Could be wrong, but I don't think they're going to work for you.
Okay, so we wrapped this up and I showed the poll results. Hopefully you can see. Mostly we do have rarely and occasionally as our primary answers. And there is a lot that can be done in the tunnel to manipulate disease before you have to resort to using a pesticide. But it is important to know a little bit about pesticides in high tunnels because there are some specific laws that apply to it. So the first thing that's important to realize is that fungicides are very different than human medicine. So when we're sick, we take a drug and that helps us get better. Fungicides are actually more protective and preventative. So think of it as armor on a knight that's preventing damage from happening. So in order for a fungicide to work, it needs to be put on healthy green tissue. If your plants are already covered in leaf spots, the fruits are rotten, the fungicide is not going to cure that disease. It only works to protect healthy plant tissue. So oftentimes when we're looking at using a fungicide, it's either because we've been scouting and you found disease just starting on the lower leaves and you know in the past that it's really gotten quite bad, and so you make the decision to protect the rest of the green healthy tissue that's on that plant, or because in the past you've had significant enough disease that you've decided this year you're going to protect your plants with fungicide sprays, and you start that even before the disease begins. But it has to be a preventative application. So if you're waiting till there's a lot of disease and then using a fungicide, don't expect that to be effective. That's just not how they work. What's important to understand too is that applying inside a high tunnel is different than applying in a field, and it is because of the ventilation inside of a high tunnel. The air movement is just not the same as what you would have in a field situation. So legally, a high tunnel is considered a greenhouse for pesticide application. And what that means is when you are purchasing a product, some kind of a pesticide to use in a high tunnel, if you read the label, some of them will say prohibits use in a greenhouse. And in that case, if it's prohibited use in a greenhouse, you cannot use it in a high tunnel. Okay. If the pesticide either says allows use in greenhouse or for use in greenhouse, or it says nothing about greenhouse, it doesn't say it allows it or prohibits it, it just doesn't mention it, then that would be acceptable to use in a high tunnel. And I should say this is specific to Minnesota. If you are joining us from another state tonight, make sure to check with your local state Department of Agriculture and how they interpret the pesticide law for high tunnels. There are different interpretations in different states, so you want to make sure you know what's right for your state. Wherever you are, you must read and follow all label instructions whenever you're using a pesticide. Okay. So I'm going to pause here for a second. What we just covered were different ways to either prevent the pathogen from moving into the high tunnel or helping to remove it once it has gotten started. I'm going to move on to another category, but I'll pause for a minute and see if there are any questions at this time.
We do not have any questions yet. I think we can, just in the interest of time, maybe keep moving, and we'll, folks think of them as we go. Please put those in the chat.
That sounds great. Yep, we've got still material to cover here. So I'm going to move on to talking about the environment. So environment plays a really critical role in plant disease. The fungi and bacteria that are commonly causing our leaf spot, leaf blight, fruit rot type infections really need moisture on the foliage and on the fruit in order to infect, to reproduce, and spread. So keeping leaves and fruit dry can significantly reduce disease. Some of our other pathogens, viruses, our little squash down here has a virus problem, phytoplasmas and nematodes. These organisms are less affected by moisture simply because the nematodes may be in the soil or in plant material, and the viruses and phytoplasmas are actually inside the plant tissue and even inside of plant cells. So they're actually well protected from the drying of the environment. But the fungi and the bacteria that we see causing these leaf blight, fruit rot type diseases are really strongly affected by moisture. So our high tunnel environment gives us a really strong advantage from the field environment because we're able to manipulate the environment much more. And so there's a couple of diseases that we can actually relatively eliminate or significantly reduce simply by moving into a high tunnel. And there are some fungi and bacteria that spread by splashing water. And down in the bottom corner here, you see a picture of Septoria leaf spot. This is a really common tomato disease here in Minnesota, and particularly in years like 2016, where we have regular rain events, this can devastate a tomato crop. But if you put it inside a high tunnel, we hardly see this disease at all. And that's because the only way Septoria leaf spot moves is by splashing rain and water. And so if we see it in a high tunnel, it's typically limited to one plant that's close to a vent or close to a door. Maybe there's a drip on the ceiling or something. But it doesn't spread and it doesn't cause significant damage. So we're able to avoid some of these pathogens. We do want to use drip irrigation and make sure that we do have it set up so that if we do have a rain event, the vents are closed appropriately and we're not getting significantly splashing from a field crop or anything. What we do see are different diseases thriving in a high tunnel environment, and they tend to be the pathogens that really like high humidity or just need dew to start an infection. And so powdery mildew is actually much more common in a high tunnel than even in field crops, although we see it in both. Leaf mold is a tomato disease that rarely occurs in the field environment. If we have a lot of rain and humidity, it will, but is much more common in a high tunnel environment because it really likes 85% humidity or higher, and so it thrives in that high humidity. Early blight is another one that we see both in the field and in the high tunnel. Unfortunately, this one moves by splashing rain, but also on air currents, and so it needs the high humidity, but it can blow around, and so we do see it in both environments. So in the high tunnel, we need to think about the humidity that's building up in our tunnel during the day and the condensation at night. And I added a link in the handout for you about managing humidity in the greenhouse. And if you follow that link, there's a really nice detailed article that talks about the different moisture changes and different things that you can do to reduce the humidity and keep your plants dry indoors. So what happens is that during the day, the high tunnel warms up and we get moisture evaporating from the soil, and we also get the plants losing water to the atmosphere. And so we start to build up a lot of humidity in the high tunnel. And if we have the vents open, some of this will be blown out, and that's a good thing. But we're building up a lot of humidity in there. And what we know is that temperatures, when the air has a high temperature, it can hold a lot of moisture. And so we won't necessarily see dew forming on the plants, but we'll have a lot of moisture in the air. But then when nighttime comes, if we close our vents up and this air is trapped inside our high tunnel, as the temperature drops, it loses its ability to hold on to that water, and what we get is condensation. And the condensation starts to form as the water filters out and it settles on cold surfaces. So we often see it forming on the plastic itself. It'll form on things like doorknobs or cold things like that, pipes. But then it can also form on the fruit and on the leaves if they are cool enough. And particularly if we have moisture forming on the plastic and it forms in enough quantities, it can start dripping down onto the plants. And that's when we start getting too much moisture sitting on those plants, and it favors our fungi and our bacteria. So my question here for our next poll is, let me open it here. Where is the hottest air in the high tunnel? It's the center of the peak, in the crop canopy, at the soil level, or next to the side vent. What do you guys think? Okay, I'm going to go ahead and close the poll. So you now got your 20 seconds to enter in your answer there. Okay. All right. And I see that most of you got this correct. That's the center at the peak. And so, of course, our hot air rises, and so we're going to have really hot air at the peak of the high tunnel. The most humid air tends to be in the crop canopy, and that's what we would like to change too, is we want to move the humid air out and make sure we have, particularly as night falls and the air temperature starts to drop, we want to make sure that our humidity is low enough in the high tunnel that we're not going to get condensation on our plants. So there's a couple things to think about. There is a wetting agent that can either be sprayed on or be part of the formulation of the plastic. And what this does is it causes the condensation on the plastic to run down the sides and fall on the sides as opposed to dripping down on the plant material. My little picture up in the upper corner here is gray mold. Gray mold really thrives with that dripping sort of condensation. And so we don't want that coming down on our plants. What we do want to do is we want to base our plants for air circulation and stake them and prune them. So this is going to mean a lot of different things because we do have a number of different styles of high tunnels, different styles of ventilation, and you may be growing determinate tomatoes, you may be growing peppers, you may be growing indeterminate tomatoes. And so you really need to think about how does air move through your high tunnel and how can you get air circulating in between the plant canopy to move out some of that humidity. Because remember, your plants are doing transpiration, and so they're putting a lot of air, moist air into the atmosphere. A lot of that humidity is coming from the plants themselves, and we want an air current to move through that to reduce the humidity. So staking, pruning, and just spacing can really help with that. It's also really important to remove weeds, both within the tunnel that are crowding it, but also outside the tunnel that might be blocking your vents. Open the side vents and the doors or the end walls to make sure we increase this airflow. You can see this is a Haygrove style tunnel, and so it's got really nice ventilation right through the center here and also even on the sides as well. The ends are completely removed in this case. If there is an end wall that's not removable, you want to think about opening those side doors and possibly adding one of these vents at the peak to get some of that really hot, humid air. In some tunnels, there is a ridge vent option, which is a vent at the very top that allows some of that hot, humid air to come out. So you want to think about allowing that hot, humid air to be released into the environment before the temperatures really drop and at nighttime. So that means in the evening, having the vents open to let that hot air out before you close them down for the night. Another technique, because when it gets tricky, is at the ends of the season where it's really hot and sunny during the day, and then temperatures at night drop significantly, and you really need to get those sides down to protect those plants. And so you want to do some ventilation before we get into those cold enough temperatures to let that hot air out, and then let some of the cooler, drier air in and drop it down. Using supplemental heat can also help reduce condensation, because more of that moisture will actually stay in the air as opposed to condensing on the plants. There's a couple different tools available to help you measure humidity, and just because we do have so many different styles of tunnels and types of plants and options for staking, it's nice to be able to have something that shows you how your humidity is changing. So a sling psychrometer is this yellow and black tool on the right-hand side here, and it's two different thermometers. One of them's wet, one of them's dry, and you basically whirl it around like a kind of a party favor, and then take the two measurements, and it comes with a chart that'll then tell you the relative humidity. So this is something, if you've got different spacing, different ventilation, you could take measurements and see which one is giving you lower humidity, and then make that your regular practice. But you do have to be out there taking the measurement and doing it. A little more hands-off option are data loggers. This is just one option, but these are basically little computer programmed monitors that come with different sensors, and they often will measure humidity, temperature, and you can get probes to even measure things like leaf wetness, soil temperature, soil moisture, and they can give you a lot of different information. They're often taking data every minute, every 5 minutes, and then you can download it on your computer. So a little more expensive, but it is really nice because they can tell you what's going on in your tunnel pretty much all throughout the day. Think about soil moisture too. It's really difficult to keep the air humidity down if you've got water in the tunnel. So when choosing a site for your tunnel, choose a well-drained site. Many people actually will build up the area a little bit before constructing the tunnel, and you want to think of improving drainage prior to construction. When you're irrigating, again, drip irrigation is the best to keep the canopy dry, and you want to water just enough for the plants. You don't want to see any kind of puddling or extra moisture forming in the in-between rows. If you do have continuously wet soils, you need to do some investigation and figure out what's going on there. Check for irrigation. If there's leaks, you want to promptly repair them. If it's water coming from outside, figure out a way to redirect that water. If it's just really a low spot, you can use something like raised beds to kind of lift those plants up. And these are just two different disease problems we see associated with kind of moisture, overly moist soil, and freestanding water in vegetable production. Okay, so I've got another question for you here. Can plant pathogens move in runoff water? And you should be able to see that in your screen there. Oh, good.
And folks, I think we'll end up going a little bit long tonight, but I don't think we'll go any further than 7:10, 7:15, something like that. So hope everybody can stick with us. If you do need to head out early, that recording will be available to you.
Great. Okay. Okay, we're closing the poll, so go ahead and enter your answer if you get a chance to do that. Okay, I'm going to go ahead and show you the poll results, and it looks like the majority of you got this correct, that yes, some of them can. Not all of them. Some of them, they all have different strategies that they use to infect a crop. But we do see, for example, black rot is a bacterial disease that goes to cabbage and broccoli and cauliflower, basically all of our cole crops. And it will move with water that's running through the field. And so I mention this because it is important when you're placing your high tunnel to think about how water moves through your farm and moves through your fields. And you don't want to have water draining off of a field crop and running into your high tunnel. If that's the only place to put it, then find a way that you can redirect the water so that as it comes off the field, it goes around the high tunnel and not into the high tunnel, because there are plant pathogens that can be carried in on it. All right, the final piece of our puzzle here is looking at the host plant. So is there a way to take the susceptible crop out of the equation? We do want to grow the crop, but we do want to also think about different ways to reduce disease. And so one of our strategies is to rotate crops. And the idea here is that many plant pathogens can survive in infected crop debris. So if our tomatoes have a leaf spot disease and those infected leaves get buried into the soil, the pathogen is able to survive there. And the next year, when water hits that soil, those fungi or bacteria will be splashed onto the lower leaves of the next crop. So many of our plant pathogens infect crops in the same family. There are a few pathogens out there that go to multiple different families, and you have to watch out for them. Rotating often doesn't work very well for those. But as a general rule, if you rotate between plant families, you can help to reduce the pathogen population before a susceptible crop is put back into that situation. And you want to rotate between families every 2 to 3 years. On average, there's kind of a rule of thumb that the fungi that are leaf spot, fruit rot diseases can survive 2 to 4 years, and the bacteria are 1 to 2, sometimes 1 to 3 if they're in a thicker piece of plant material. So moving away, making sure that plant debris breaks down and the pathogen population is reduced along with it before coming back with a susceptible crop. Okay. There are also resistant varieties, and on the handout that you can download on the web page, I listed one website that Cornell maintains, which is a series of charts that helps you look for different resistant varieties for different crops that can be really useful. So a resistant plant is a plant that can defend itself from a pathogen. And in some cases, like our fusarium-resistant tomato down here at the bottom of the page here, it's very successful at resisting the pathogen, and you will not notice infection. You won't notice symptoms of disease. In other cases, the resistance is either partial or moderate resistant. Sometimes these are sold as tolerant, and oftentimes in those cases, you'll see some signs of infection. So you'll see some powdery mildew, but it won't become as severe as a plant that is 100% susceptible, and you'll be able to get a better yield out of your tolerant or your moderately resistant plant. It is important to know that resistance is specific to one pest or pathogen. So if you see an advertisement that just says good disease resistance, that doesn't mean very much. The resistance is actually very specific. So what you want to do is have a diagnosis of the pathogen that's causing the problem, and then look for resistance to that specific pathogen or disease. So in this case, we have a tomato spotted wilt virus resistant tomato. And so it's resistant to this virus. It's not resistant to other diseases. It's just resistant to that one virus. So it's important to know what pathogen you're dealing with so that you can pick out the appropriate resistant variety. Another option is grafting. Grafting is basically putting a susceptible scion, the top of the plant, into a resistant rootstock. And so it's very effective if you want to grow something like heirloom tomatoes for their specific color and flavor or shape. But if they're susceptible to things like fusarium wilt, verticillium wilt, corky root, or nematodes, all of these are pathogens that infect through the root system and in the soil. And so we take a resistant rootstock, you can see here, and then you put the susceptible scion on top of it. And they're grafted together, and so the roots are able to resist the pest or pathogen, and the shoots produce the type of fruit that you're looking for. It can be costly, and so unless you have one of these particular pathogens, it may not be worth your while to use grafting until you need to. And then I do have a question for you here as well. Will root grafting protect plants from leaf spot and fruit rot diseases? Yes or no? Oops, and I think I need to open that. Okay, I'm closing that, so we now have our 20-second time limit here. Okay, we'll show those poll results. Yes, and it looks like the majority of you got this one too. Yeah, the correct answer is no. So because the resistance is specific to a specific pathogen, it's very applicable to things like fusarium wilt, verticillium wilt that are infecting through the roots, but it's not going to provide resistance to leaf mold or early blight. Some of them do give you a little bit more vigorous growth, and so that might compensate for infection, but you're not going to see true resistance to the foliar pathogens because the foliage is actually from a susceptible variety. Okay, just to wrap up and review what we talked about tonight, when we're looking at disease control in the high tunnel, there's a couple different routes we can take. So we want to keep pathogens out by using clean seed and transplants. Make sure that our tools, our workers, and anything we bring in like compost, straw, or manure is also clean and free from pathogens or herbicide residue. We want to control weeds, particularly perennial weeds or weeds that are in the same plant family as the crop. Tend to be the very problematic ones. Remove infected plant parts, so once disease does occur, go through and do some good sanitation. Make sure you have a rot bucket that is not also your harvest bucket. You want to keep it separate from the clean, healthy fruit, but a good rot bucket to pull out infected fruit, infected plant parts, and get them onto the compost pile where they can break down rather than spreading through the tunnel. Use fungicides. Remember, these are protective and preventative, so they need to be applied to a healthy plant. So you catch the disease either very early and then apply, or you apply completely preventatively. Make sure you know what diseases you're dealing with. Use the clinic, use the online resources. There's a lot of information available, and then that information can help you choose a targeted control strategy. For the manipulation of the environment, this is actually a really nice tunnel. You can see there's a lot of good ventilation happening on the side vent here. And in this case, he's also got an example of a ridge vent to vent hot air out of the top of the tunnel. So manage your ventilation and plant spacing to reduce humidity and condensation in that tunnel. Use drip irrigation to keep the foliage dry, and make sure you choose a well-drained soil or improve the drainage of the area so that the soils are not part of the humidity issue. Okay. As far as the crop goes, rotate crops as much as possible, ideally 2 to 3 years. But if all you can afford to do is go tomatoes 1 year and something else and then back to tomatoes, even 1 year away from that crop will provide some time for that infected plant material to break down before you come in with a susceptible crop. So do rotate as much as possible. Use resistant varieties when they're available. Remember, they're specific to just one plant disease. Some of them have been bred to have resistance to multiple, but then they'll list all of the different diseases they are resistant to. Grafting can be very effective for soil-borne diseases, things like the wilts that we see here in Minnesota, and make sure to control weeds both inside and outside of the tunnel, as they can also be a host to the certain plant pathogens. And with that, we'll wrap it up. I am only 8 minutes over according to my computer, but I am happy to stay on and take any questions that anyone might have.
All right. We don't have any questions in the chat right now. If anybody would just do me the favor of saying hi in the chat just to confirm that it is working for you. I know that we had a few people chat earlier, so would appreciate that. So we'll give you a little bit longer to give us some questions. Michelle, do you want to pass me the control again, please? All right, people are saying hi in the chat. That's great.
There we go.
All right. Yeah, we don't have any questions. I did post the website for the handout location in the chat. If you think of anything else, any questions, please do that. These are the different resources that she posted on there. So some really good ones. I will plug that What's Wrong with My Plant tool. I use that frequently myself for questions that come to my office, and it is excellent. It's very visually based and very easy to use. And so you'll see on the website, that's where they are under resources there. Let's see. So we will be emailing you an evaluation. So we will, again, I want to just plug filling that out and just giving us some feedback. There is a Facebook page for this program. You could just do a local foods college, University of Minnesota search, or that's the address there. Grab onto that. If any of you are out there using Twitter, we're using the hashtag Local Foods College. The Regional Sustainable Development Partnership is kind of the lead on this program, and they are at RSDP. And then I am tweeting under UMN and Small Farms. Next week, we will be with Lisa Baker, who's a farmer here in Minnesota, and has put together a lot of really good resources and guidance for vegetable farmers on how to harvest, how to plan your harvest, some of the logistics, some of the supplies, the process, the infrastructure, lots of good ideas on how to do things. So I would recommend that you join us next week. Let me just double check on our chat. One question, a little bit more of a general question. On average, how much can high tunnels extend the growing season? As in how many weeks? And they're a northern Minnesota producer.
Yeah.
Go ahead.
Oh, I'm not sure I have a good answer to that question, particularly with the variability in our season these days. Yeah, it's going to depend a lot on the actual year and then how much you're willing to put in as far as supplemental heating in the beginning and the end of the growing season. This last year we had an incredibly long season, well into November, and yeah, I'm sorry, I don't have a really good answer to that.
Yeah, and part of she's wondering how cold is too cold, and like you said, it'll kind of depend on the setup, but it is possible to maintain production through the winter, but that takes a lot of investment. Let's see. I don't know if I see any others. Double check our Q&A. All right. I think for the most part, that should wrap things up. If you want to use your applause emoji for Michelle, now would be the time to put that one on.